Hello and welcome back. We now look at a few common data types in Python. We've already seen previously the basic data types such as int, float, strings, or booleans. These are suitable to hold single values, but often we want to create a more complex data type that can hold more than one value. One of the data types we frequently encountered are lists. Lists are sort of containers or sequence of elements, and we can initialize a list either with an empty list or with a predefined sequence of elements. For example, we can say my empty list square bracket defines an empty list, or my list square bracket 1, 2, 3, 4 square bracket, and we can see that the square brackets indicate that we want to create a list. Just as any other variable in Python, we notice that we just assign a list to a variable. Now that we have a list, we can print it and use the length function to determine the length of it. For example, we can say print the list, and the list has 4 elements. And we probably want to extend lists. There are multiple ways to add new elements to a list. We can append an element to the end of the list. We can insert one at a specific index, or we can concatenate two lists by sort of adding them together, where the plus doesn't really mean add, but we concatenate the list. So let's look at how this works. We could have my list and append 5. So 1, 2, 3, 4 becomes 5. This is the first print statement we see here. We can also add a new element in the middle at the index 2. So we add the number 3 at index 2. So we see here 1, 2, 3, now the new 3, 4. Or we can concatenate the list 1, 2, 3, 2, 3, 4. We sort of add them by concatenating them, and that becomes 1, 2, 3, 2, 3, 4. Some common list operations are sorting them, and if we use the argument reverse equals true, it goes the other way. We can count how many times a given element occurs, or we can reverse there. We can also find the position or the index of the first occurrence of an element with a specific value by using the index function. Now, as an exercise, take the list below, sort it in ascending order, and count how often the number 2 appears. Just as we want to add elements, we may also want to remove elements from a list. The clear function removes all elements from a list, so we have an empty list. Or we can remove an item at a specific index. This is by using pop. If we omit the index, it uses the last one. Or we can remove a specific value. If this value doesn't exist, we get an error. So, for example, we have this list. We want to remove the first occurrence of the number 3. We've already encountered the indices when we use the lists. They are very important, and we need to spend a bit more time for understanding how indices work. So let's say we have the list my list 1, 2, 3, 4, 5. Now we have two kinds of indices, and we've used the so-called forward index so far. Note that we always start counting at 0. So the first number has the index 0, the second element has the index 1, and so on. Now we also have the backward index. Here, the last value, the 5, is always -1 as an index, -2, -3, and so on until we arrive back at the first value. So the number 1 has two indices. It's either 0 for the forward index. The backward index is always indicated with a minus sign. And notice that we start counting from 0 with the forward index, and to avoid confusion, we start with -1, the backward index. Now we can use this to access elements of the list. We can print the full list, for example, or we can print the third element, which has index 0, like here. If we want to access the last element, for example, or any other, it really works with any element. But for the last element, it's particularly clear. Like we have this list, and the last element in the forward index has index 4. We could also use the length function. It's 5 elements, and we need to subtract 1 because we start counting from 0. Or we use the backward index with -1. So in each of these cases, we get the number 5. So we see there are 3 ways of accessing the elements. One key thing about lists are that they are mutable, so we can change the elements. For example, we can override and assign at the index 2 a new value. So 1, 2, 3, 4, 5 becomes 1, 2, 10, 4, 5. We can also access ranges of lists via the index. So far we've only had one specific element, as we did with the number 2 here, but we could also have several parts of this, a range. And the general syntax is start index colon, stop index colon, step size. MyList, and if we omit any of these, colon is the same thing, as we can see here. We can also say, instead of starting from 0, we start from index 1 and print from them. Or as an exercise, do this yourself. There is also a connection between lists and strings. In a way, they behave quite in the same way. We can almost, but not quite, interpret a string as a list of letters. In this sense, at least, we can access elements of the string using indices. However, crucially, strings are immutable. Once created, we cannot change letters in the indices. Let's say we have the string I love Python. Then using the index function, we get the index of the first occurrence of the letter P. And then we can print parts of the string, just as we would for a list. As its exercise, use indices and slicing methods to print the word run from the word nurse below.